Hi, everyone. Thanks for taking time out of your day on a very busy day for many of us, routines starting and first days of school, to be with us to talk about one of my favorite topics, heat pumps. My name is Anne White, and I'm the director responsible for developing Canada's green building strategy, and I have the honor of welcoming you to today's event. When I started my role with Natural Resources Canada on greening buildings a little over a year ago, I met my associate Drew at a summer picnic, and he was wearing a I Love Heat Pump t-shirt, and I thought, wow, he's really into his job. But as I listened to a friend explain the benefits of his new heat pump to a group of about 20 parents this weekend, I was thinking back to that t-shirt and how I need to get one. It's a really good conversation starter, and that's what we need right now, people talking about heat pumps at picnics and kids' birthday parties and by the office water cooler. Heat pumps are an essential technology to help us get to net zero in the building sector. And while they are a mature technology in much of the world, they're still new to many Canadians. So I'm excited about today's panel and the opportunity to learn practical solutions to accelerating heat pump adoption in Canada. Big thank you to Brian Flanagan and the Building Decarbonization Alliance for bringing these experts together today. It couldn't come at a more important time. I also wanted to say thank you to many of you who have participated in the public consultation for the building strategy, and to let you know that while the consultation period for the strategy is officially closed, the work continues, and we're always happy to speak with you as we finalize the strategy. You can always reach out to me directly. Brian, over to you. Thanks for the opportunity to introduce this important event.
Thank you, Anne. We're all just extremely grateful of the working relationship that we have with you and all of the hardworking staff at NRCan. Of course, I'd like to also welcome all of our participants today. We're really humbled and quite overwhelmed by the response to today's session. Just shows how topical and front of mind this issue is. But before we proceed, I'd really like to begin by having us all, reflect for a moment on the spaces where we live, work, and play, and how we all interact with the land. Our organization, the Transition Accelerator, has staff all across the country, across many provinces. And so we acknowledge the traditional territories of the Indigenous peoples on which we work and live. We recognize the ongoing relationship that Indigenous peoples have to the land, and we firmly commit to the ongoing process of reconciliation. Now, as I mentioned, I have the privilege of serving as the Executive Director of the Building Decarbonization Alliance, or BDA for short. The BDA is a nonpartisan and cross-sector coalition working to change the narrative on building heat, to really inspire and inform industry and government leadership, and to really meaningfully accelerate market transformation. As a first step in this endeavor, we're convening stakeholders from across industry, utilities, civil society, and government to form our coalition. Our aim at the Alliance, in a nutshell, is to just kind of get past the rhetoric and to really lead and engage with evidence and science. And to that end, we're conducting original research, helping put in place the conditions for effective policy, and really increasing awareness of the benefits of decarbonized all-electric buildings, casting our minds forward to envision what that future would look like and how amazing and resilient our buildings can be. You may have seen our recently released report called The TwoWay to Heat Homes, which presents what we think is a really good analysis in support of potential regulatory interventions to encourage adoption of heat pumps instead of air conditioners. And that's just one example of our work. In the coming months, we'll be making announcements on a new pace of progress analysis, which will really serve to benchmark and track adoption of heat pumps in the building sector. And later in the fall, we'll be announcing the release of Canada's first open source building and use decarbonization model, which we believe will really advance our mission by increasing the analytical capacity of the sector to really delve into the issues and understand the implications of some of the policy recommendations that might be made. And today's session is another example of our work, working as an initiative of the Transition Accelerator, sharing lessons learned and understanding the experiences of other jurisdictions in their journey to decarbonize buildings. If this and other building electrification topics are of interest to you, I would be remiss if I didn't invite you to and encourage you to consider becoming a partner of the Alliance. Joining the Alliance is simple. There's no fees. You can just go to our website, review the partner declaration, and submit your request to join, and that's pretty much it. And then you'll become aware of all of our news and stay up to date on the progress of our work. Now, with that, it's my great pleasure to introduce my colleague, Natasha Reid, the Director of Analytics and Insights at the BDA, who is leading the development of the National Open Source End-Use Building Decarbonization Model. Natasha started her career as an electrical design engineer, first with BC Hydro, then Newfoundland and Labrador Hydro. And in 2019, Natasha joined a local startup called NISA Thermostats as product manager for utility initiatives. She worked with utilities across North America to help integrate smart technology into their grids. In 2021, Natasha moved to France, where she pursued her master's degree in global energy transition and governance at the Centre International de Formation Européenne. Her thesis focused on how Canada can unlock demand-side potential through residential demand response. And we all know how important load flexibility is going to be as we move forward. I've been working with Natasha for several months now. I know that Natasha is a passionate advocate for environmental conservation and sustainability. She sits on both the Smart Grid Innovation Network Board of Directors and the Newfoundland and Labrador Greenhouse Gas Reduction Fund Advisory Council. She holds a Bachelor of Electrical Engineering from Memorial University of Newfoundland and is a registered professional engineer with Professional Engineers and Geoscientists of Newfoundland and Labrador. Welcome, Natasha. Thank you so much for moderating today. Over to you.
Thank you for that introduction, Brian. I just want to say welcome, everyone. We're so happy to have you here at this webinar focused on international lessons for heat pump adoption. As Brian mentioned, we recently released a paper, The Cool Way to Heat Homes, and it highlights how heat pumps are the most efficient means of space heating. A single-stage heat pump will on average produce 220% more heat energy than it consumes in electrical energy. And variable speed cold climate units can run at an efficiency of up to 400% or more. Despite this, Canadian households are not on track to electrify their space heating by 2100, let alone 2050. Canada's adoption of heat pumps is increasing, though. Between 2018 and 2022, ducted heat pump sales increased by 18%. However, we know that we must pick up the pace, and that is why we have brought on international experts to talk about heat pump adoption in their countries and in their jurisdictions so that we can really learn from the different experiences that they've had. So we're very happy to have with us today Nate Adams and Jan Rosenow. I have the honor of introducing them. So Nate, the House Whisperer Adams, is the author of the Home Comfort book and has helped numerous clients make their homes healthier, more comfortable, and able to run on clean electricity. He and his partners have adapted the upgrade process into the HVAC 2.0 program, which gives HVAC contractors a business model to deliver the same results for their clients while enjoying their work more and being more profitable. His focus on residential electrification retrofits earned him the moniker, the father of Electrify Everything, from Panama Bartholomew, CEO of the Building Decarbonization Coalition. He splits his time between living on the Cuyahoga River in Ohio and in a former West Virginia coal mining village with his wife and young daughter. And he's joining us today from West Virginia. So welcome, Nate. We also have Dr. Jan Rosenow, Regulatory Assistance Program, or RAP, Director of European Programs. As a Director of European Programs, Dr. Jan Rosenow leads RAP's initiatives in Europe on power market design and efficiency first. He is responsible for all aspects of leadership, management, and financial viability of RAP's work in Europe. Dr. Rosenow serves on the Executive Committee of the International Energy Agency's Demand-Side Management Program and sits on the board of the European Council for Energy Efficient Economy. He has also advised the International Energy Agency, the European Commission, the European Parliament, and the U.S. Agency for International Development, the German Cooperation for International Cooperation, government departments in a number of countries, and the UK's Office of Gas and Electricity Markets, as well as serving as an expert witness on several occasions to the British Parliament. He was the lead author of the International Energy Agency's Global Assessment of Market-Based Instruments for Energy Efficiency. Dr. Rosenow also has a strong track record in energy research. He is an honorary research associate at Oxford University's renowned Environmental Change Institute. He has authored more than 70 publications in the form of peer-reviewed papers, technical reports, and conference papers. He has also served as an expert witness to the House of Commons. In 2020, Dr. Rosenow was elected to be a Fellow of the Royal Society for the Encouragement of Arts, Manufacturers, and Commerce in light of his long-standing dedication to moving the UK towards a more sustainable and resilient energy future. Prior to his engagement with RAP, he worked closely with the European Commission's Directorate General for Energy through his policy work for the global consultancy Ricardo. Dr. Rosenow earned several postgraduate qualifications, including a master's degree in environmental policy and regulation from the London School of Economics and a doctorate from Oxford University. So welcome, Jan. So I'm going to hand it over first to Jan and then to Nate to deliver some presentations that they have prepared to just give a background to this topic and kind of open up the discussion. Then I'll be posing some questions to the panel, and then in roughly 30-35 minutes, then we'll open up to questions from the audience and attendees, which you can enter in the chat. So without further ado, I'll hand it over to Jan.
Thanks, Natasha. That was quite an elaborate introduction there, quite long. So I hope we haven't lost people with all the detail. I'm going to give you a sort of 5-minute snapshot of what happens with heat pumps in Europe, and it's boiling hot here in Oxford from where I'm talking to you. It's a heat wave at the beginning of September, so it's rather odd to talk about heat pumps. But of course, the winter is just around the corner, and the heating season is about to start. So many of you will have probably seen media coverage about the energy price crises in Europe. May have seen some of the reactions to that, and one of the reactions amongst many is that heat pumps have accelerated quite a bit in Europe, and I'm going to talk you just briefly through that and maybe highlight sort of the overarching trend that we're seeing, then look a little bit at which countries are leading the race in Europe. There's quite a few surprises there on the list. Then look a little bit at which countries have already installed heat pumps historically, not just in the last year or so, but we look back sort of for the last 2 decades, where has most of the stock of heat pumps in Europe been installed. And then I think we will move over to Nate, who will cover similar thoughts on the US, and then move on to the discussion. So next slide, please. So on this slide, you see the annual installations of heat pumps in Europe used for heating. Just to be clear, this does not include air conditioning systems just used for cooling. These are all systems that are used primarily for heating. And the majority of these systems are quite different to, I think, what is used in Canada, certainly in the US. They're not air-to-air systems, or what you might call an HVAC system with ducting in the house. These are often air-to-water systems. We have radiators where water gets pumped around. What you see here is that when you go back 10 years, Europe installed about 750,000 units per year. And then you fast forward to 2022, sort of last year, and for the first time, Europe managed to achieve 3 million heat pumps to be installed in a single year. And you can see the growth and how it's accelerating in the last 2 years in particular, almost 40% last year of growth, which is pretty remarkable for any market. But when you zoom in a little bit, and that's on the next slide, you can see that there's huge variation, which countries are installing heat pumps at what pace. So here you see the number of heat pumps being sold per 1,000 households in 2022. The reason for that is that if you just look at total numbers, there are vast differences between countries. You may think of Germany, about 85 million inhabitants, compared to a country like Norway, with a much smaller number, less than 5 million people, I believe. So you can't really compare total numbers. That's why it's been equalized per 1,000 households. And what you see here is that the leaders, this is last year, Finland, Norway, Sweden, Estonia, Denmark are all countries in the north of Europe. And then France is also quite a big market. And at the bottom of the list is my home country, the UK, where I currently live, the worst performer on that list. But quite a bit of variation, when you sort of look where these heat pumps get deployed. And the same is the case for the level of growth that we have seen. One country in particular, Poland, has achieved, I think, 140% expansion in a single year last year. So that is quite remarkable. Next slide, please. I already mentioned that the leaders last year were mainly the Nordic countries. And on this chart, you see not the sales in a single year, but the total stock of heat pumps. So this, in other words, this shows you, how many heat pumps there are per 100 households. That is the x-axis. That means the further you are on the right of this chart, the more heat pumps are installed as a stock. And then on the left-hand side, on the y-axis, shows you the number of heating degree days, which is basically an indicator how cold it is, how many really cold days you have. Surprisingly, you see that the countries with the highest number of heating degree days, i.e. the coldest countries, are also the ones with the most heat pumps installed, which often people find surprising because we sometimes hear that heat pumps don't perform well when it's cold. Nate and I will go into that later, I'm sure. Well, this data shows you that actually, most heat pumps in Europe, at least, are installed in the coldest regions. One of the reasons being that that's where most of the heat demand is, and the economics of sort of saving energy are more important than perhaps in a country like Spain or Portugal, where heating isn't such a big energy user. Next slide, please. Just zooming in on one particular country here, Norway, which is the unrivaled leader in the world, I believe, in terms of heat pump penetration. In Norway, roughly 2/3 of all households now have a heat pump. And you can see on the left-hand side, it's quite hard to read, but you don't need to see the detail here. You see the number of heat pumps sold per year historically, and you really see that this only happened over the last 2 decades or so. In the 1990s, the sales were very low indeed. And only in the last 20 years, we've seen this rapid deployment. On the right-hand side, you see the emissions from household heating in Norway. Again, you can't see the detail here, but you don't need to. You can just see the trend of emissions going down quite significantly by more than 80%, roughly. And on the left-hand side, of course, that growth in heat pumps. There are lots of other factors too. Buildings have become more efficient, for example. But heat pumps clearly were a very important driver of this. Next slide, please. And I think I'm almost at the end. This is my last slide. And this is just showing you what happens in Poland, a country that is kind of at a very different stage of development of heat pump markets. I mentioned before, I think, the very high growth last year. But in terms of stock, Poland hasn't applied a lot of heat pumps to its buildings in the past. What we see here is that after rooftop solar was installed in very large numbers over the last 4 or 5 years or so, heat pumps are kind of following that trend. And there is evidence that businesses are deliberately targeting customers with solar to also install a heat pump at the same time, because there are some economic benefits to be had. So that's an interesting picture there as well, how fast emerging economies for heat pumps are starting to really expand their heat pump markets. So that's the kind of, in a nutshell, what's happening in Europe. There's, of course, a lot more nuance to this, and we will go into that later on. But I just wanted to give you kind of a helicopter view where Europe is moving. Lots of different speeds in Europe, but overall, pretty aggressive growth that we have seen. Thank you.
Thank you so much for that, Jan. Yeah, I really liked that graph that showed the different countries and where Canada was, and try to figure out how we can move that farther along to the right on that axis and seeing which countries are leading. And it looked by the percent growth that the adoption has been growing faster in European countries than Canada. So thank you for that. We did have a question on slide number 7 from Stephen Pacifico. Do you think we can go back to slide number 7? So Stephen said, how can you have 4,500 heating degree days in 1 year with 365 days? Am I reading slide 7 wrong?
Let me double check. Can I get back to you on that?
Sure.
I'm seeing the same thing. There might be a bug with the graph. Let me just double check that and get back to you.
I actually
okay?
know that one.
Oh,
Jan.
okay.
So that is a measure of, I'm used to thinking in Fahrenheit versus Celsius, but say you're trying to keep the indoors of the home at 20 degrees Celsius, and that day is 5 degrees Celsius outside. That means you would have 15 heating degree days for that day. So that's how you can have more than one per day. So
Right.
like, again, I'm not used to staring at it in Celsius, but Cleveland is about a 6,000 Fahrenheit heating degree day climate. The really ugly ones, like North Slope of Alaska, get to about 18,000 in Fahrenheit. So it'd be about 9,000 Celsius. But in any case, you can have many, many heating degree days. It's part of how we size HVAC.
Wonderful. Thank you so much for that insight, Nate. That's very helpful. Maybe we can pass it over to you now to your presentation that you've prepared.
Great. So thanks for having me. Appreciate this. And Natasha, I appreciate you mentioning at the beginning that Canada is not really even on pace for a 2100 home decarb, let alone a 2050. And 2050, we think it's possible, but it is a really narrow path. So we view it like this, where it's very, very narrow and it's a steep fall off on either side. So we have to be very cautious how this is done. Next slide. And I just want to back up really quickly, just for those that aren't used to this technically, heat pumps and air conditioners from a North American perspective. So one thing that's really strange about the North American systems is we have ducted air conditioners and ducted furnaces, which are primarily unique to the US and Canada. There's a little bit in South America, there's a little bit in the Middle East, but in general, we have our own type here. Where what Jan is talking about is more of a boiler system that runs through radiators, so it's hot water that's used to heat instead of the air. So just a quick thing there. And I don't know the numbers in Canada, but in the US, about 90% of homes have a duct system. Some also have boilers, like in the Northeast, but it's a huge proportion of homes in both the US and Canada have ducts. So that said, it's important to note that heat pumps and air conditioners are like the same car, but with and without reverse. So at first I put some ICE cars in here, internal combustion engine cars. I'm like, wait a minute, what am I doing? So put a Bolt and a Tesla in. So the ones on the left, they look exactly the same, but these don't happen to have reverse as just a theoretical look, where the ones on the right do have reverse. So they look almost identical. And they function exactly the same. Basically, heat pumps just have a couple of extra parts. One is called the reversing valve, which lets the refrigerant flow either way. So that's like adding the reverse gear. And then it needs a defrost board, which determines when the outdoor unit is turning into a literal block of ice and tells it to defrost itself. So if you are looking at the same unit, so most air conditioners have a heat pump model, and the cost difference for the parts in them, according to the DOE a couple of years ago, is $150. So I put in $100 to $300 spread because I haven't seen updated numbers. COVID threw everything off, so Lord knows right now. But there's not a whole lot of difference here. So, well, the paper that you all just put out was actually based on a US paper called Hybrid Heat Homes, which was based on a Twitter thread that I put out about 2.5 years ago. So it's just kind of funny watching all of this. I'm glad the idea is spreading. It's good. All right, next slide. So really important note, you may have seen news articles that heat pumps in the US are selling at the same volume as furnaces. That's great, and that's a big shift. You can see the heat pumps on the right there, how they are up significantly over the past decade. But note on the left, the central air conditioners, We're still in the US selling about 6 million a year. And my understanding is the Canadian market's very similar to this. You may actually have a little higher air conditioner to heat pump split. But until we change all 6 million of those central ACs over to be heat pumps, we are not on the path to decarb. Next slide. Really important note. So we were just talking about heating degree days. This is a little bit different way of looking at it. This is called bin data. So this is how many hours climate spends in a certain temperature range. Now, apologies that I use Cleveland, that it's in Fahrenheit. I had this available, but the concept here will hold everywhere. So 750 hours is roughly a month. So if you look at, say, one of the tallest bins on the left there, the 30 to 35, that's right around 0 Celsius. And in Cleveland, we spend about a month in that bin. That is really good heat pump territory. Most heat pumps are still working really, really well to freezing and a bit below. So even though Cleveland is considered a very cold climate, the vast majority of the work can actually be done with a heat pump, even if it's in a hybrid. And a hybrid is a heat pump paired with a furnace instead of the standard air conditioner paired with a furnace. Next slide. And what that means is about 90% of the year is actually great for using a heat pump, even if you have some form of a furnace as backup. So your backup heat can be whatever. It could be electric resistance. It could be a gas furnace. It could be a propane furnace. It could be wood. Whatever you choose for your backup, the heat pump can handle the vast majority of what most climates need. Now, this gets tricky when you get really, really cold, but even in Canada, most of it isn't that cold. Next slide. Now, from a market perspective, I'm just trying to stay zoomed out here as much as I can today. But residential electrification, it has 2 key parties. These are the only 2 parties that actually matter at the end of the day, because one writes the check and the other one does the work. So all the rest of us that are involved here are extraneous. So that's really important to keep in mind. And both of these people have to be convinced. And I joke that this is like one of the worst blunders is getting into a land war in Asia, like out of The Princess Bride, one of my favorite movies. Like we have, again, apologies for just thinking US based, but we have 100 million homeowners and about 100,000 contractors to convince in the US to get all this to flip. So it's a lot of work and it's a bunch of individual things. Next. Now, one really important thing that I want to note, be careful telling contractors what to do. This is a hilarious GIF that I found a couple years ago from Futurama of Bender coming up to a sign that says boating prohibited and folding it into a canoe and sailing away. So if you tell people what to do, they're very likely to push back. So be very, very careful telling people what to do. You want to ask them what to do and facilitate things, but be very, very careful of any perception of ramming things down people's throats. So like hybrids, one way we like talking about it is this is not getting rid of air conditioners. This is actually doubling consumer choice of heating fuel source. So we are increasing heating fuel choices is what we're doing by adding heat pumps. Next. Then from the consumer side, we need to think about the adoption curve. So if anyone here hasn't yet read Jeffrey Moore's Crossing the Chasm, I can't recommend it highly enough. And basically the market is separated into 2 pieces when you've got a new piece of technology coming out. So you have the early market, which those are your nerds. I tend to be one. And then you have your mass market that they want to make sure that it's well sorted, followed by the skeptics at the end. Like I think about my in-laws, who I love to pieces, but the only reason they got smartphones is when they couldn't get flip phones anymore. And so we need to be thinking of from a mainstream perspective, which is different. Next. All right, so there are 2 critical challenges that we have to do to have a shot at 2050. So the first is we need to be installing 100% heat pumps by 2030 because these systems have a 15 to 20 year lifespan, maybe 10 on the bottom side, 15 in the middle. But if we aren't installing all heat pumps, meaning no more air conditioners by 2030, 2050 is off the table, period, because it's a 15 to 20 year replacement cycle. Second, 80 to 90% of HVAC replacements are emergencies. So they get replaced when the furnace or the air conditioner breaks. So we have to deal with that as well. So if we can't deal with both of these challenges, we fail, at least to hit 2050. Next. And this is how I divide it in my mind. So I think of this as two clocks. So the first clock would be from 2020 to 2030, getting us from low penetration of heat pumps to 100% penetration of heat pumps. At that point, then we begin to work through all of the existing stock, but that's still going to take 20 years to play out. But until we get to that 100% of every replacement system involves a heat pump, we can't move to where 100% of all systems are heat pumps. Next. And this is another funny gift that I found, actual footage of a homeowner with a broken air conditioner on a hot day, which all of us have experienced more of this summer than we have in the past. This has been a pretty tough summer. So when your air conditioner goes out or your furnace goes out, like your air conditioner goes out, you're frankly unlikely to die. If your furnace goes out in a cold climate, you better worry. You better find someplace warm to be, because the climate for all of us in northern climates, which is all of Canada, the climate will kill you in the winter if you don't have heat. So clients tend to freak out, and now they are stuck with a very large expense, one of the largest expenses that you bump into in adult life. You know, buying a house, buying cars, roofs, and HVAC are basically your biggest purchases. So now you have this huge purchase that you weren't expecting. So what are you going to do? Maximize it or minimize it? Of course, you're going to try to minimize it. Next slide. Now, the only way that this works is if air conditioners are in stock, they're a little bit less money, not a lot, usually $300 to $700 is what we see. It's not a huge spread if you're looking at the same piece of equipment. I'm not talking going from basic to upper level. There's a big spread there, but that's true of all equipment. But if you're looking at a basic air conditioner to a basic heat pump, if heat pumps aren't in stock and basically the same price, the air conditioners are going to get chosen. And so I noticed this from a number of reports in Chicago where very, very few heat pumps are available. So if 85% of systems are emergency replacements and there isn't a heat pump on the shelf to install, what gets installed? An air conditioner. So that's the piece that has to get broken and changed, or else we're going to continue in status quo. Next. So the easiest solution to all of this, that went back to that thread that I wrote 2.5 years ago, is turn all one-way air conditioners into two-way heat pumps. And sometimes the one-way and the two-way can be a good way to think about it. It's funny, I was talking to my wife the other day, who's been listening to me talk about decarb for years, and she's like, I still hate the name heat pump. I'm like, well, the industry's used to it. So to a degree, we just have to double down and educate. But I might suggest calling them two-way heat pumps. The Australians call them reverse cycle air conditioners. So kind of a similar sort of phraseology. But it's important for people to understand we are definitely not taking your air conditioner away. We are actually giving you an extra heat source. And to this note, by the way, the city of Vancouver has now done this. And they've been running it for about 6 months. And I don't know if you all have had Chris Higgins on, but it may be worth talking to him. So it's been a much easier transition than he expected. The distributors actually love it because they have about half the units to stock now. They don't have to stock air conditioners and heat pumps of the same sizes and varieties. It's just all heat pumps. So it's actually been quite successful thus far. And that's a pretty easy climate for heat pumps as well. I mean, that's one of your mildest climates. So, okay, I think that's it. There's one more, I think. So just the takeaways that we have noticed from trying to figure out how do we actually decarb. The church of the kitchen table is really critical. The homeowner and the contractor needs matter above everyone else. The two clocks, the first clock, we have to get to 100% heat pump installs, no more air conditioners, and do it in a way that is not politically difficult. It's a bit easier for you all in Canada versus here. This is a very difficult lift in the United States. And then it's also important to remember that we are early adopters. Everyone here, you are an early adopter. And we basically, if anything that we say can be replaced with CrossFit or vegan, you're doing it wrong. So don't push too hard. Let people come along. What we find is most useful in being at the kitchen table is helping understand what comfort problems clients have and what indoor air quality or health issues they have in their home. And we give them options to solve those problems that involve a heat pump, because they really should. And so, as another friend of mine puts it, he's like, if you want people to eat vegetables, put vegetables on pizza. So that's my suggestion from that, and I hope that was helpful. And I saw some questions, so now to go look at them.
Yes, thank you so much for that, Nate. I really appreciated that explanation. And like you said about that thread that you posted 2.5 years ago, that we've kind of like turned into this paper, and you see a movement happening in the city of Vancouver, like that's exactly what the kind of like conversations and lessons learned we want to facilitate in this discussion. Is basically like we're all working towards the same goal, and we're all trying to like draw on each other's expertise to be able to reduce emissions globally. So yes, I really appreciate all of that, and I think maybe we'll wait for the audience. I know there's a lot coming in. Wait for the audience questions. We have about like 25 minutes set aside just to talk to the panel, and then we'll get into the audience questions. So Nate kind of touched on some of the barriers and challenges for heat pump adoption, about it being around 80 to 90% emergency replacement, not having heat pumps in stock, having AC in stock, and then the price point. I'm curious, Jan, what do you see as some of the main challenges, whether technical, regulatory, or cultural, that's being faced when it comes to heat pump adoption in Europe?
Thanks. A great question, Natasha. And it depends on where you are. I think is quite an important distinction between countries, but the workforce constraints are particularly prevalent, of course, in countries with low levels of heat pump adoption, where markets are suddenly moving much more rapidly. Germany, for example, is a good example of that, where I think last year some companies would tell you have to wait a year, maybe 1.5 years, until you get even a survey done, because they were fully booked. And in other countries, very mature markets like Norway, I mentioned before, almost 100% of all new heating systems are now heat pumps in Norway. So that is the entirety of the market, and there are no installers of gas boilers or gas furnaces or oil boilers or gas oil furnaces. It doesn't exist. So very different situation. But certainly with equipment, COVID had a significant impact. I think components like semiconductors were an issue, but even more simple components like the rubber feet of the outside unit of the heat pump were not available for some time. So there were constraints. I think some of those constraints are unblocked, but there are also manufacturing constraints. It takes a bit of time to upscale. In Europe, many of the companies have invested heavily. I think over the last 12 months or so, when you add up all the investment announcements, there's about 5 billion euros of investment. I don't know how to convert that to Canadian dollars, but it's a fairly sizable amount. And all of the big manufacturers are now expanding and building new factories. That's going to take a bit of time. So yes, there are some constraints, but the main constraints, I think, in the medium to long term, are not so much to do with the workforce. I think that can be overcome, but it's really the structural barriers that exist in many countries. And that is, for example, the ratio of electricity prices to prices of other heating fuels. Traditionally, Europe used a lot of cheap fossil gas imported from Russia primarily, and also oil was cheap for a long time. And electricity was facing a carbon price, lots of policy costs to support renewables, things like feed-in tariffs. So that ratio of electricity price to other heating fuel prices is still a problem in many countries. In Belgium, for example, or the UK, it's a barrier, because even if you get a very efficient system, let's say you get a 3 or 4 times higher efficiency, if your electricity to gas and oil price ratio is less than that, is bigger than that, you actually have a problem, because you don't get any cost savings. So I know it's the same for in the US, depending on where you look at which state, whether the economics add up, but it's one of the key factors that still plays a very, very significant role. But it's becoming something that policymakers try to address. I mean, I could talk more about how you can change that and what you can do about it, but it certainly has been a very major barrier. You know, the economics simply didn't add up often, let alone the upfront cost. I mean, that is another big barrier. You can tackle that with grants and things like that, but often heat pumps have been simply more expensive to install. So if they're both more expensive to install and more expensive to run, why would you do it unless you really committed to reducing carbon emissions? You know, that is now moving, but we're still seeing that as a significant barrier in Europe.
Thank you very much, Jan. Maybe we can discuss a little bit if this is also a barrier you're seeing in the US. Like, obviously, it needs to make economical sense for people to want to invest, unless they are the very nerdy early adopters. One thing in Canada, though, is we do benefit from relatively low electricity rates compared to other OECD countries, especially in Quebec. I think it's among one of the cheapest in the world. So we're lucky that, like, I know there's been the energy crisis in Europe, but that's not something that is as big of a barrier here, I guess, as opposed to those other countries. Yeah, Nate, I'd love to hear your thoughts on this as well.
Well, it's an important thing to have an idea where the ratio is. And I mean, ballpark where you want it to be is electricity is typically about triple the cost of natural gas, give or take. So it can vary up and down. But if you have a system that's 300% efficient, but it costs 3 times as much for the fuel, the actual fuel cost overall is equal. So where you want to do is see where do those go. Like the state of Michigan is awful for economics. In Norway, Sweden, and Finland, one of the big reasons it's so popular there. So cold climate heat pumps work quite well down to minus 20, minus 25 Celsius. I get really comfortable at minus 40 because that's super cold in both. That's where they cross. But they have inexpensive hydropower, just as Quebec does. So Quebec's very heavy on resistance electric heating, which is kind of wild because it's so expensive to do it that way. But their power is very inexpensive. So yeah, watching that ratio is important. Now, in the class paper for hybrid heat homes, we specifically chose 41 degree Fahrenheit or 5 degrees Celsius changeover. And the reason for that is with this basic single stage piece of equipment, that is where you stay above a 3 COP. So that's 300% efficient. And so that made the economics work pretty well. And with that changeover in the United States, we found that would lead to a 39% reduction in fossil fuel heating usage. And you can obviously go way lower. So there was another question about where's the changeover point for Cleveland. That answer can vary, but we swung for the fences and set it at 5 degrees Fahrenheit, which is around minus 15 Celsius. And some systems will hang on to that. You have to know your heat load and the output of the heat pump. There's a lot of design pieces that go into that. But we routinely see 80 to 90% reductions in natural gas usage after installing a hybrid, when you set the hybrid up to swing for the fences and work as hard as it possibly can. So there's big variances in what can happen. But the hybrids are, as frustrating as they are in not being pure, one of the best steps that we can take next, and that will get both consumers and contractors used to the technology. So the next step, going full heat pump at the next equipment replacement, won't seem foreign.
Thank you very much, Nate. I would like to talk about the contractors piece, because obviously if we're talking about retrofitting and installing heat pumps in 2/3 or 75%, depending on the country, that's a lot of work that needs to happen. Do we have the manpower and the workforce and the expertise to do so? How can we prepare that better? What is the user's experience like now if they are inquiring about a heat pump? I don't know, maybe Nate, if you want to take that one first. Sorry, Jan, you can go first. And then
maybe add to it. I mean, what we see in Europe is that there is now a significant initiative from the manufacturers of heating systems to retrain some of the installers they've been working with. You know, they have very close connections, of course, to the installer base, And there are training programs for them where they can learn how to install a heat pump. And so that we already have a lot of installers, of course, who can install fossil fuel heating systems. In Europe, that is gas boilers and oil boilers primarily. And they have skills that are very much transferable. I mean, heat pumps are different, right? You're also dealing with electrics there, and it's quite a different technology, but many skills are transferable. And we've also seen examples of companies like Octopus Energy in the UK, for example, who bought an old warehouse on the outskirts of London, and they train about 1,000 people every year in the warehouse on a live live project. They have a real house rebuilt in that warehouse where people can test how to install different types of heat pumps and learn it and standardize it. So there are programs like that, and many of the people who they train are former oil and gas installers, system installers. So there's lots of momentum. But it takes time, of course. And I mean, my view has always been, once there's kind of clarity where things are moving, then the industry will make the investment, will invest in the training. But if there's no clarity, then it's kind of a chicken and egg problem. For those people who want the early movers find it difficult to actually get a good installer. There might not be quality assurance. That's another big area we could talk about, to get high quality installs versus people who actually don't know what they're doing and put bad heat pump installs in, and then they get a bad reputation. That has happened in several countries before at the early stages. So it really depends on, I think, the long-term certainty for the companies where things are headed, and in some countries that's very clear, in other countries less so. But I think it's a surmountable barrier, but it is a real barrier, no question about it. Nate, what do you think? How do you see it from your perspective, working with installers perhaps much more closely than I am?
Well, in North America, it's actually far, far easier because air conditioners and heat pumps have essentially the exact same install process. There's very, very few differences. The primary one being oftentimes you need a few more wires going to the thermostat. But a good install should include pulling a new wire to the thermostat anyway, because oftentimes they get nicks or cuts or something on that, and it can cause weird issues later. But it's maybe a half an hour extra install time. So that's another thing where it's nice too, if you stick to sizing your heat pump to cooling load rather than heating. Typically you have enough ductwork to handle it. Because if you don't have enough ductwork, they run very high pressures inside, and that can kill the equipment very, very early. Like we hear of compressors and blower motors dying within a year or two when they're put in the wrong place. So that's one nice thing about the hybrid strategy is if you keep the equipment size a little bit smaller, you typically have fewer failures that come from that. Where full electrification, that's a big jump. So we teach people how to do this in HVAC 2.0. I pulled my first gas meter in 2014. I am 100% comfortable pulling gas meters. So we own 5 houses right now. They're all electric, pulled meters on 3 of them. So it's not necessarily that difficult, but we need just a little bit of mindset training more than anything. It's more of a psychological problem than it is a technical one for the most part. So that's the challenge, is getting people to realize, hey, this is actually genuinely better.
Yes, thank you for that, Nate. And I know when we were discussing last week prior to the session, we were saying that when people inquire about heat pump installations, that a lot of times they're actually talked out of installing heat pumps by the installer. And I'd just like to understand, like, how often does this happen, and why does this happen?
As humans, we fear the unfamiliar, and installers predominantly view heat pumps as unfamiliar. So there's certain parts of the US where they're very common. The Southeast, it's super common. Inexpensive power prices is a huge piece of it, and the right climate as well. Climate zones 1 through 4 in the US, which are all relatively mild. So like the UK would be climate zone 4, give or take, somewhere 3 or 4. It's not particularly cold, although you all have summers that are generally much cooler than we enjoy here, although not this year, sorry. You've got the American South version of summer this year, apologies. But until we get through the fear, like I said, the psychology is actually the more important piece here, because I can't tell you how many people have told me, yeah, I was told that heat pumps don't work.
It's the same here. I mean, and not all plumbers. It's usually the plumber in the UK who you first ask, if your boiler breaks down. But the majority of plumbers would not advise to install a heat pump. They will say just get another gas boiler, partly also because they might have a new gas boiler in the back of their van and it's ready to be installed. Whereas getting a heat pump is hassle. They may not have experience with installing heat pumps. And there are also, unfortunately, lots of myths that are still being spread, that's causing problems too. For example, heat pumps don't work in old buildings, which is not true. I live in a very old building, 143 years old, and we had a heat pump for 5 years, and it's keeping us very warm. But those kinds of things are being told when you ask. Some of that is just kind of learning new technology, and it's being unfamiliar. I think plays a very important role. It's a transition, that's always going to be difficult. I think it reminds me of when you go to buy a new car, a few years back. I think most salesmen wouldn't recommend an electric car, whereas I think that has really changed more recently with more models being available and familiarity increasing. But it's a journey. But it's clearly a first barrier, and many people will then stop looking because they're being told by the person who they trust, who installed the heating system, that it doesn't work for them. They shouldn't touch it. Then they're moving on and they're just installing a new fossil system, which is a real shame because I think for many properties a heat pump actually is a good choice.
Yeah, so the main takeaway here is it's less of a technical problem and more of a cultural and psychological problem. And I know one thing, Jan, you mentioned earlier about Octopus Energy training like 1,000 people a year, and that the market will develop if the right level of if the government is giving the right message that this is the direction we're going. That kind of stood out to me a bit too. Like, how can the government show that this is the direction we're going, so then the market adapts and knows that this is a good thing to invest in?
I mean, I can mention a couple of things that governments are already doing. I mean, one is that ratio of electricity to fossil fuel heating prices. That addressing that, I think, and showing a trajectory for that. So many governments in Europe have now started introducing carbon pricing also for fossil gas and heating oil, not just for electricity. So that is changing the economics, and they've set out a trajectory, going forward for the next 10 years or so. This is how those tax regimes will evolve. So that's one area. If you want to have a more drastic measure, I mean, some governments have now outright banned the installation of new fossil fuel heating systems, starting in new buildings. I mean, you've seen the same in the US. I think in New York, new buildings can no longer be hooked up to the gas grid. In Europe, that has started a long time ago already, where you cannot construct a new home that has a fossil fuel heating system in many countries, but now increasingly also in existing buildings. But that is now coming in a number of countries, but it's of course politically extremely challenging to introduce measures like that. But where they have been introduced, the clarity is there, and then suddenly we see companies that have vigorously lobbied against any change, suddenly investing massively in marketing that technology. So we are definitely seeing a shift there in how companies behave once the policy framework has moved on. But it takes some courage. It's not easy, as we've seen earlier this year in Germany, to actually do something that is more interventionist and doesn't just rely on offering people some takeaways, some grants, some sweeteners. If you use policies that have more stick and less carrot, that is always going to be difficult. But we could discuss to what extent we need that. But it certainly is something that has been introduced in a number of countries now.
Thank you. Nate, I'd be curious to also hear your thoughts on this in terms of what states are leading and what direction they've been given from the governments, that sort of thing.
Well, I should probably take one step further back. In talking to a number of the OEMs, the manufacturers. What they're looking for is just what Jan is mentioning, which is something close to certainty. So very strong guidance as to where things are going. So state by state is actually really horrific for the manufacturers. They don't want that. They would much rather see something from the federal level pushed to all the states or the provinces. And so that is problematic. And also, like, a lot of the things that are happening in New York, I mean, I am intimately familiar with what it takes to do this in American homes, particularly older, leaky American homes. So for retrofits, it's really challenging. For new construction, building them tight is not that hard. It's just not. We coached one builder, and within a few builds, he was down to 1 ACH 50, which will mean something to Jan. It's bordering on passive house tightness, just using traditional methods, nothing exotic. And he usually lands between 0.8 and 1.5, like nice tight homes. And those you can run air source heat pumps with a little bit of resistance. You can run ground source if you like. I'm not a huge fan because I think it's too expensive for what you get from it. But if we create a patchwork, it could make things more difficult rather than less. So one nice thing about Europe is the countries are essentially the size of states or provinces. So forgive me, I should know exactly how many Western European countries there are. It was about 15. Something like that. So it's like 15 states.
It depends how you define. Yeah, like in the EU, there are 27. Used to be 28.
Okay, there you go. So that's a bit more than provinces in about half of the states. So that's actually almost an easier thing to tackle. And they have full control in many cases, where I don't know how the regulations work in Canada for building codes, but in the US, they're all enforced by individual cities, which are enforced by individual inspectors who may or may not want to push the bar. So I see a lot of things get overlooked. So if we rely on enforcement in general, we find that is a path to failure. It is better to change the supply in the first place, if at all possible, which is another reason that we suggested let's change air conditioners to heat pumps. That's a unique North American thing, by the way. We are the only ones that get to do that.
Yeah, we definitely have like a decentralized government model in terms of provinces really owning the building codes, as well as the electricity generation, transmission, and distribution. So yeah, it can be a challenge to have a coherent message. We're almost done this time before we transfer over to questions from the audience. Before that, we've quickly touched on the performance of heat pumps in cold climates. We talked about the Nordic countries. We talked about hybrid a bit. We talked about the psychology, and the reality is the past experience can be a barrier for people. And a few decades ago, heat pumps did not perform as well as in cold temperatures. Should we be installing heat pumps in Canada? Is this something that people should be concerned about? What lessons have been learned from like the cold climate installations that you are both familiar with that we can transfer to Canada?
I can maybe jump in, and then I know, Nate, you've I think thought about different parts of Canada and how they might compare, and where heat pumps already will be suitable, and we can be confident that they will deliver comfort at good efficiency. We actually have a new paper out that's going to come out next week, early next week on the 11th. That's we asked ourselves the same question, because we get it all the time. But what if it's really cold? What in cold climates? So we've collected all field studies. So this is not theoretical modeling, but it's actual data monitored from real installations in different countries, including Canada, but also the US and parts of Europe, and compiled it all into one big data set to see how does heat pump performance actually change when it's getting really cold outside, not just freezing, but way below freezing. And there are some interesting results. Of course, performance goes down, as you would expect. But also what we found is that even at quite low temperatures, and I think, Nate, you mentioned minus 20 Celsius before, I think, we find that even down to minus 20 degrees Celsius, which I can't convert to Fahrenheit, I'm afraid, in my head.
It's around zero minus 5. Yeah, very, very cold.
Even then, the efficiency is still pretty decent. Of course, it depends on the kind of heat pump that is installed as well. And the other thing that we're seeing is that cold climate heat pumps are becoming better and the technology is improving. So that is happening at the same time. But the data that we have, and of course it's not the full data set, it's not everything, but it's the data that we can find, tells us that performance is still pretty good. Of course it is dropping with lower temperatures outside, but it's not dropping off a cliff, which is sometimes suggested. And certainly what we conclude is that in Europe, there is no reason why heat pumps should not be able to perform, given that temperatures on average in Europe are very rarely below minus 20 degrees centigrade.
Yep, that is a really good explanation. So in general, below minus 20 Celsius centigrade, things get more difficult. Not impossible, but yeah, it's important to note that it's a downward slope for performance, but it's not like it falls off a cliff and stops. And some of the systems now are good to minus 40, which I'm comfortable with, like I said, because it's the same in both. It's extremely cold in Celsius and Fahrenheit. But below minus 20, things get hard, not impossible. But down to minus 20, performance can be quite good for the cold climate. But if we're talking about single stage, that is a little bit different. They do start to lose significant ground in, say, the minus 5, minus 10 range of their output. But you can still work with that. So it doesn't mean that they don't work. It just means they have less output. So then you need to get in whatever your backup heat source is. But that's single stage. And with cold climate, I'm very comfortable just ripping gas meters out of houses all over the place. It's just, you need to understand the heat load. You really need to understand what it takes to heat that house on a cold day. But if you have a very accurate view of that, it takes all the fear away. I'm just not afraid of it anymore.
Okay, awesome. Thank you guys so much. I'm going to transfer over to some of the questions from the audience. One question from Steve Pacifico. He would love to know if there was a strategy in play or incentives or policies that help move to the market and supply chain for heat pump adoption. I know we talked a little bit about economic incentives guiding market trends and like the government stepping in and adjusting like gas prices, that sort of thing. I'm not sure if either of you would like to take this question.
If I can take this one, there's another one in here that I wanted to mix in.
Okay, sure.
We think it's very important to run either midstream or upstream incentives.
Mm-hmm.
So incentives that don't affect the kitchen table and put a choice in front of the homeowner.
Mm.
Ideally, you let them have whatever it is. So that's why we're suggesting heat pumps instead of air conditioners, period. So that could be midstream, giving the incentives to the distribution of it, so your supply houses and whatnot, or it could go to the manufacturers at the top of the chain. But I have yet to see, and we've been looking for a decade, a downstream program. That's where it affects the kitchen table transaction and equipment selection. We have yet to see one of those not add friction to the process and make the sale harder, not easier. So that's in considering programs, if we can please stick to midstream and upstream, please. The IRA programs in the US, they're making our lives on the ground significantly harder, not easier. And I can't tell you how frustrating that is to someone who really gives a damn about this.
Let me add briefly that, yes, the answer is yes. There have been lots of strategies and policies. Some of them failed, some of them were successful. And again, this is an interesting question. What actually works, right? Well, which policies work, which policies fail? What does a good strategy look like? And we've published a paper at the climate conference in Egypt last year where we launched it on this very question. And I think it's called our Heat Pump Policy Toolkit. You can find it on our website. And it's trying to distill a lot of complexity and case studies into, what are the key pillars that you actually need. It's simplistic, but I think it's still accurate. One of the factors, structural imbalances between prices. We already talked about that, overcoming the upfront cost, and you could do that in the way that Nate described, or you could have grants. That's a common program that's being used. And then finally, some regulatory measures as well, especially in new buildings where often the market first starts to really emerge, build the supply chain, and then you also get into existing buildings after. So combining structural incentives, incentives to install the equipment, and then dealing with some regulatory measures to provide clarity and certainty is a combination that is often used and has successfully been used. And therefore, if countries are looking at this, they may well be well advised to copy some of that and at least have some elements of policy in each of those pockets.
Awesome. Thank you, guys. We have a lot of questions, so I'll probably move on to the next one. We have a question here from Dave about, can you speak to ducted versus ductless heat pumps? He says, we've done ductless installs with compressors on balconies. I know that in the area I am, we have a lot of resistance heat as well as Quebec because we have a lot of hydropower. And so we don't have those ducts already running through the home. So a lot of people want to supplement with the ductless heat pumps. So what are your thoughts on that?
I might as well go because I know these systems pretty well. So if you only have radiators and you don't have a duct system, yeah, ductless is probably going to be one of your primary tools. We are much bigger fans of ducted mini splits, where like particularly for running like a bedroom or multiple bedrooms, you'd have one small unit that runs all of them. Because you can't buy heads, the actual unit that goes on the wall or in the ceiling, you can't buy them small enough for the vast majority of rooms. So you end up with it being oversized, which can lead to various comfort and weird efficiency outcomes. So if you don't have any ductwork, at least try and consider a ducted one. And it's funny, just last week, every Monday we do a show called the HVAC 2.0 show, and we tackle one subject or another. We're aiming mainly at HVAC contractors, not so much homeowners, but some of the shows are more friendly than most to homeowners. Last week was on the title was why mini splits mostly suck, and we were mainly thinking about ductless, but sometimes you don't have the option. So that is what it is. The ducted ones we much prefer in large part because they're much better for air quality. You can mix the air in the house, you can filter the air in the house, you can dehumidify, you can humidify, you can bring in a little bit of outside air and inject it into it. There's a lot of different pieces that you can do. So our preference is that, but we're also very pragmatic in what we do. So you do what works reasonably well and go from there. Placing the outdoor unit can be challenging, as that one comment mentioned. So, and sometimes there's nothing you can do about it. It depends on which house you're working on or apartment.
Thank you very much. I have a question probably for Jan, because this one is about air to water systems that you mentioned were common in the Nordic countries. So Elizabeth says, to understand, that means the potential for heat pumps with radiators is higher than heat pumps with duct-based HVAC. Do air-to-water systems work better than air-to-air in cold weather climates? And yeah, I guess understanding why it's more popular for the air-to-water in the Nordic countries.
It's actually, just to clarify, it's air-to-air systems that are particularly prevalent in the Nordic countries, not air-to-water. By Nordic, just again to be absolutely clear, I mean Finland, Norway, Sweden, Denmark. The majority of systems, if you add up all the numbers, which I have done, it's more than 80% air-to-air systems. Air-to-water is much more common in countries like Poland, in Germany, in the UK, in Belgium, simply because you have a heritage of what we call wet systems. You know, you have radiators already installed in all of the rooms. You might even have a hot water tank. So that system is already there, and that's what people are familiar with. And changing that to a ducted system will be a massive change. It's a completely different system. Whereas if you can leave the radiators in place, that finds more acceptance from customers. In terms of efficiency, I actually think an air-to-air system may be slightly more efficient potentially, because you have, it's less complicated. It's a less complicated system. They don't really, I don't think there's a massive difference essentially between air-to-air and air-to-water. You can get pretty good efficiencies with both. But the main reason for air-to-air systems being so widespread in the Nordic countries is an absence of your water-based heating systems in the first place. And I think this goes back to a point Nate made earlier on, that seems to hold also for parts of Canada, lots of resistive heating that have been replaced with heat pumps. So if you use electricity for heating and you then install a heat pump, you get an immediate running cost savings because you reduce the electricity consumption so dramatically. So that's another reason why air-to-air is more prevalent in the Nordic countries. And then architecture is another question, a more open plan historically than perhaps in other European countries, which made it easier to use air-to-air systems because you don't need to deal with individual rooms in the same way that you have to deal with in other European countries.
Yeah, I appreciate that clarification, Jan. That's quite helpful. So it's sometimes not about just efficiency, but the existing infrastructure and what would work best for a retrofit. So that makes sense. We still have a lot of questions, but unfortunately, I don't think we're going to be able to get through them all. We can provide contact information if you'd like to reach out afterwards about specific questions in terms of heat pumps. But before we close, I would like to hear from Nate and Jan if there's anything that we haven't discussed that you would like to mention, mainly around lessons from your experience that we can apply to accelerating heat pump adoption in Canada, knowing that we are a Nordic country with cold temperatures, relatively cheaper electricity depending on the province. Yeah, I'd love to hear your closing remarks. I don't know if you want to go first. Maybe Nate, you're unmuted. So
okay, like we've been both pointing to, this is a psychological battle, much more so than it is a technical one. So that is where we want to focus, and ideally, like I'm very much a free market person. I'm well known for this on Twitter. So this is not taking a choice away. This is adding a heating fuel choice, but I would prefer that air conditioners just aren't on the shelves anymore. That is by far the simplest path. You can fund it, and it's not that expensive. I mean, the class paper, we came up with between 6 and 12 billion for the U.S. to do the whole U.S. for a decade. This is not an expensive program. We have multi-trillion-dollar budget, so it would be about a tenth that, like most things for Canada. So if you were helping pay for the cost difference of the equipment, that would be that. Or Vancouver just said point blank, no more air conditioners. And that was that. And they haven't had a great deal of pushback there. So it depends. But this is primarily a psychological game. And a lot of it is, how do we get heat pumps to where they're acceptable to the mass market, like I was showing in the adoption curve. So what do we have to do to make the jump across the chasm and focus on that? Because almost everything I see is focusing on the early market, which means we aren't going to get across the chasm. That's what we're trying to do in HVAC 2.0, is continuously figure out what is the path to the mass market.
Yeah, just adding to it, I would agree with Nate's point there. I mean, the technology is pretty mature. It's still innovating. We get, it's getting better every year, but we're not talking about a really early stage technology here. It's widespread in many countries already, and that shows that under the right conditions, it can achieve very high levels of penetration. But it's a massive communication challenge for sure, because it touches people's homes, right? I mean, you're trying to install a new system which they're not familiar with. It also requires the workforce to be on board, and the companies themselves. There's a big shift, but I think past transitions, when we look at other transitions in the heating space, have been quite similar. There was resistance against moving from coal to gas in the UK, for example. Now unthinkable, but people cannot really remember that anymore. There has been huge resistance by, of course, the coal industry at the time didn't want the gas to take over. There were concerns by installers whether the new systems would work, concerns by homeowners whether they would be warm, etc., etc. And now, when you fast forward a few decades, that's become the new norm, right? And people compare everything against that. So I think it's a difficult transition, but it's doable, and we know that because we have done it in the past, maybe for other reasons than we now look at it from a climate perspective much more. But I think we can be confident that it's doable under the right conditions, and it can be done in Canada too, but it needs to be done in the right way. It needs to be done in a way that it doesn't result in any sort of unintended consequences. So lots to learn from other countries that have already done this.
Well, thank you both. I really appreciate you lending your time, and you're both a wealth of knowledge, and we really appreciate your insights and discussions today. And yeah, I also just want to highlight the fact that I know Jan said they're having a heat wave in Oxford. Like we've been having a heat wave here as well, in Quebec and Ontario at least, and also this summer has been like some of the worst forest fires our countries have ever seen. So also just being able to give the population access to air conditioning, which the majority of the population doesn't have in this changing climate and changing time, is very important. So really great discussions here. We had a lot of audience participation. I also appreciate all the questions from the audience. I wish we could have gotten to everyone. We have been recording this session, which we'll put up online. And if it's okay with Nate and Jan to share the slides, we've had some requests for that as well.
Absolutely.
That's okay?
Welcome to share my email as well.
Okay, excellent. Well, thank you both.
Pleasure to be here. Thank you.
Thank you very much for having me.
All right. I guess that's kind of it for a wrap. What an amazing session. I'll just add a couple of words to summarize. There's so many takeaways. It could take a little while, obviously, to digest it all. I hope it was thought-provoking for all of you as much as it was for me. In sessions like today, I'm always reminded that we're sort of really at the very beginning of this particular market transformation. We're at the very bottom of the S-curve. But we have accomplished other transitions in the past, as Jan reminded us and pointed to. Of course, there are many questions and many gaps and issues to address. That's why we're here, after all, to foster those conversations and to try to mobilize our knowledge as best as we can and share the things that we think we know so far. Lots of questions from the audience, as Natasha mentioned. We've captured all of those, and kind of one of our modus operandi is to use those questions then as a basis to address issues, questions on labor adequacy, affordability, the dynamics between new construction and retrofit, which are very different, clarifying technologies like cold climate heat pumps, air to water, et cetera. We're all very interested in hearing your questions and then working overtime to respond to those. I particularly like Nate's point about not, telling people what to do. We're here to foster dialogue and to listen, so that really resonated with me. And as a program designer for most of my career, I also really appreciated the recommendation and insights on midstream and upstream programming, working with the supply chain instead of end users. We've seen similar friction and challenges with local sort of end user based downstream programming here in Canada. So that really resonated with me. Also really looking forward to Jens' literature review and data on the performance of heat pumps in cold climates. Again, the BDA is here to share that type of information and resources and data. So making those linkages is welcome. And so in closing, thank you very much, Nate and Jan. It was an amazing session. I want to also thank Anne White from Enercan for kicking us off. And of course, our own Natasha Reid for moderating today. For sure, it goes without saying that we want to thank you. All these sessions are way better when we have a wide audience. We had, north of 100 people participating today, which is great. And we really appreciate your time and attendance today. If you enjoyed this webinar, follow the Transition Accelerator and the BDA on our social media feeds, sign up for our newsletters, come out to our websites, and there'll be more of these types of sessions going forward. And if you would like any more information on becoming a partner in the BDA, please reach out. That's it for now. Thank you all so much, and enjoy the rest of your day.